What if the place humanity longs to call its second home is already marked by a flaw so deep that no dream can overcome it? For thousands of years, Mars has glowed in the night sky like a red ember drifting in the dark sea of space. It has been a lantern of desire, a symbol of both danger and destiny. To the ancients, it was the god of war. To the modern imagination, it is the next frontier. Mars shines with a deceptive beauty. Its deserts stretch beneath a thin veil of atmosphere, a world painted in rust and fire. It is close enough to touch with the eye, near enough that spacecraft have already traced its valleys and plains, yet far enough to remain untamed. To humanity, it has become the cosmic promise, a refuge waiting beyond Earth's fragile cradle. But every ember carries the memory of fire. Every dream hides its shadow. Mars is no exception. Beneath the poetry of its crimson glow lies a truth more difficult than the void itself. The very forces that shaped this world, its gravity, its atmosphere, its climate, have woven into it a silent resistance to life. Here, the flaw is not a single problem of engineering or technology. It is written into the planet's being, etched into its history by physics and time. It waits like a quiet guardian, challenging every vision of cities beneath domes and fields beneath alien skies. The question rises: when the laws of nature oppose the will of humanity, which will endure? Since the dawn of wonder, eyes have turned to the Red Wanderer. In ancient skies, Mars drifted like a burning coal, moving against the background of stars with a will of its own. The Babylonians marked its path, the Egyptians recorded its cycles, and the Greeks gave it the name of Ares, god of war. To Rome, it was Mars, the restless bringer of battle. Every civilization that gazed upon this crimson world saw not a planet, but a symbol, a celestial mirror of human struggle, ambition, and destiny. Mars became a story in the heavens, written in the language of myth. Its changing brightness foretold omens. Its strange retrograde motion puzzled astronomers for centuries. Yet beneath the veil of superstition lay a truth no one yet knew, that this wandering star was not divine, but another Earth waiting to be revealed. As the telescope opened human eyes to the unseen, the dream sharpened. In the late 19th century, Percival Lowell believed he saw canals etched across the Martian surface. To him, they were not marks of geology, but the grand works of an intelligent race fighting for survival on a dying world. He wrote with conviction that Mars was alive, that alien engineers had carved rivers of salvation into a desert planet. Though later disproved, Lowell's vision ignited the modern imagination. For the first time, Mars was not merely a point of light. It was a world perhaps inhabited, perhaps reachable, a canvas for human hopes and fears. The 20th century transformed speculation into obsession. Mars became the stage for science fiction's boldest tales. Writers like H.G. Wells gave it invaders who threatened Earth with their superior machines. Others painted Mars as a cradle of ancient civilizations lost beneath dust and ruin. The red planet grew into a metaphor for humanity's greatest anxieties and desires, the dream of other worlds, the terror of the unknown, the possibility of finding not solitude, but company in the cosmos. Then came the age of machines. Rockets left Earth not with myths, but with instruments. NASA's Viking landers touched down in the 1970s, sending the first clear images of Martian soil. There were no canals, no cities, no monuments of alien hands. Instead, there were endless plains of rock, a sky tinted butterscotch, and silence stretching beyond the horizon. Yet that silence was not disappointment. It was invitation. The lifeless beauty of Mars only deepened the mystery. If no civilization had built canals, perhaps humanity would be the first to leave footprints there. The dream pressed on. Spirit and opportunity rolled across the red deserts, uncovering evidence that liquid water once flowed. Curiosity followed, drilling into ancient rocks that preserved the chemistry of habitability. Perseverance arrived with the promise of collecting samples that may, one day, reveal signs of life's faintest whispers. Each mission has been a brushstroke on the same canvas. Together they sketch a world that, though barren today, once bore rivers, lakes, and perhaps even oceans. A world not alien but achingly familiar. The discoveries stirred more than science. They awakened ambition. If Mars once held water, why not again? If it once had conditions for life, why not for life renewed? No voice has echoed this vision louder than that of Elon Musk. With SpaceX, he speaks of making humanity a multiplanetary species, of building cities beneath the Martian sky, of safeguarding human survival by spreading civilization beyond Earth. His words, amplified by rockets that pierce the atmosphere, have made Mars not just an object of study, but the blueprint of our future. In this vision, Mars is not the red planet. It is Earth 2.0, a second home awaiting settlers, a refuge from the fragility of one world. Yet beneath the ambition lies the echo of older myths. For just as the ancients saw Mars as war's companion, modern humanity sees it as destiny's partner. The desire is not only practical, it is deeply human. To stand on a new world is to prove that the species is more than bound to one cradle. It is to take part in a story larger than history, to step into a cosmic narrative where Earth is but the beginning. Still, there is a paradox that whispers beneath the dream. Mars may be close, yet it is not kind. Its air is thin, its gravity weak, its climate harsher than Antarctica's coldest deserts. Radiation seeps through the skies, unblocked by a vanished magnetic shield. The very soil contains chemicals that would choke life rather than nourish it. Here lies the contrast. In the human imagination, Mars is the promise of a second Earth. In reality, it is a world sculpted by forces that resist life at every turn. It tempts with rivers long gone, with landscapes shaped by water that no longer flows. It invites with mountains taller than any on Earth, with canyons deeper than any ocean trench. Yet every invitation conceals a warning. To call Mars home is to challenge nature itself. Not only through technology, but through the defiance of planetary history. The dream is as radiant as the planet itself, glowing in the darkness of space. Yet the flaw waits, silent and immovable, written in the same cosmic script that carved Earth into abundance and Mars into desolation. Why Mars above all worlds? Why not the moons of Jupiter, the clouds of Venus, or the hidden oceans of Enceladus? The answer is as much philosophy as science. Mars is near. Mars is visible. Mars feels reachable in a way no other world does. Its deserts echo Earth's deserts. Its canyons mirror Earth's scars. Its polar caps gleam with water ice, fragile but familiar. To look at Mars is to glimpse a shadow of Earth across the void. A reminder that life's ingredients are not confined to one planet alone. Mars became the canvas because it looks like us in reflection. It is Earth's sibling, scarred and silent, but close enough to dream upon. Humanity chose Mars not only because it is possible, but because it is symbolic. It is the promise that the story of life can be written again, even if the ink of nature once ran dry. Yet the promise is fragile. The closer we come, the clearer the flaw becomes. Mars is not Earth 2.0. It is a different chapter in the same cosmic book. And the question lingers, can ambition rewrite a planet's fate? Or will the fatal flaw of Mars remain unbroken? There was a time when Mars was not the barren desert seen today. A time when the planet carried rivers that carved valleys, when lakes filled basins, and when entire oceans may have spread across its surface beneath a sky thicker and more protective than the one it wears now. To study Mars is to uncover the memory of a world that once breathed, a world that once held the raw ingredients of life, and perhaps, for a fleeting age, the possibility of life itself. The evidence is carved directly into its surface. Ancient riverbeds stretch across the landscape, winding channels frozen in stone, silent witnesses to a time when liquid water flowed for thousands of kilometers. Delta fans, broad, branching deposits of sediment, lie at the edges of crater basins, the unmistakable marks of rivers emptying into long-vanished lakes. Minerals such as clays and sulfates, which can only form in the presence of liquid water, dot the planet's crust like signatures of an ancient climate. The rovers have carried humanity deeper into this memory. Opportunity revealed hematite spheres, tiny iron-rich marbles scattered across the plains. They were nicknamed blueberries. These small, unassuming stones were born from interactions between minerals and water. Their presence whispered of an environment far wetter than the desert we see now. Curiosity traced layers of sediment in Gale Crater, strata that told the story of lakes persisting for millions of years. Perseverance now explores the Jezero Delta, a landscape that holds the chemical fingerprints of a long-lost river system. Each discovery adds weight to a haunting truth. Mars was not always a graveyard. It was once a place where life could have found a foothold. The ingredients were present: liquid water, organic molecules, volcanic warmth, and sunlight filtering through a thicker sky. If the spark of biology ever ignited there, Mars might have been a twin to Earth in more than geology. It might have been a second cradle of life, yet that promise was fragile. The planet could not hold it. Something shifted, something irreversible. A slow unraveling began, stripping away the shield that protected this young world and leaving it exposed to forces more powerful than any ocean or river. At the heart of this unraveling lies a collapse, written into the very bones of Mars. Earth has a magnetic field, born from the motion of molten iron in its core. This invisible shield deflects the solar wind, a constant stream of charged particles flowing outward from the sun. Without it, the solar wind would erode the atmosphere, blasting it away molecule by molecule. Mars once had such a shield. Geological evidence suggests that billions of years ago, the planet's core generated a magnetic field strong enough to protect its surface and preserve its atmosphere. But Mars was smaller than Earth, only about half its size. Its core cooled quickly. The dynamo that powered its magnetic field flickered and went dark. The silence of that dying core sealed the fate of Mars. Without its shield, the solar wind tore into the atmosphere, stripping it away over millions of years. What had been thick and protective thinned into a fragile veil. Carbon dioxide, water vapor, and nitrogen bled into space. The oceans evaporated, the rivers dried, and the climate shifted into a permanent winter. NASA's MAVEN mission has revealed the mechanics of this slow death. Orbiting Mars since 2014, MAVEN measured how the solar wind still interacts with the planet today. It found streams of atmospheric particles escaping into space, driven off by the relentless energy of the sun. In that data lies the record of a catastrophe that began billions of years ago, a world slowly stripped bare by physics itself. The contrast with Earth is stark. Earth's magnetic field stands as a guardian, deflecting the solar wind and preserving the air that sustains life. Mars lost its guardian. Its atmosphere was peeled away until only the skeleton of a climate remained. Where Earth's surface thrives with oceans, forests, and rain, Mars's surface is desolation, its rivers fossilized in stone, its lakes turned to dust. It is not simply the loss of water that matters. With the atmosphere gone, pressure fell. Even if liquid water could return, it would instantly boil away or freeze. The climate grew colder. Radiation streamed down unshielded. The soil became toxic with perchlorates and oxidants, hostile to the chemistry of biology. The planet was transformed from a potential Eden into a desert of silence. This was not the betrayal of chance. It was the consequence of physics. Mars's smaller size meant its core cooled too fast. Its gravity was too weak to hold its atmosphere once the shield was gone. Unlike Earth, Mars could not fight back against the solar wind. Its fate was written in its very skeleton. The emotional weight of this story lingers. Mars was once alive with water. It could have been habitable, It may even have hosted life in some form, microbial or primitive, thriving in warm lakes or underground aquifers. Yet the world could not hold on. It was betrayed by its own fragility, by the very laws that govern planets and stars. To look at Mars today is to look at a paradise lost. The rust-colored deserts are the bones of a world that once breathed. The dried river valleys are scars left by waters that fled to space. The great canyons and volcanoes are monuments of a world that promised life and delivered silence. For humanity, this realization is more than science. It is a mirror. Earth and Mars were born from the same cosmic dust, siblings in the same solar family. One became a cradle of abundance, the other a tomb of potential. The difference was not intention, but physics. It raises a haunting reflection. How fragile is Earth's own balance, and how much of it depends on the shield that Mars lost? The suspense deepens here. The flaw that haunts Mars is not just surface dust or thin air. It is deeper, more permanent. It lies in the heart of the planet itself, in the stillness of a core that no longer moves, in the silence of a dynamo that failed. No technology can reignite it. No dream can restore it. Mars stands as a testament to the power of physics to shape destiny. Humanity may dream of building cities beneath domes, of terraforming deserts into oceans, but beneath those visions lies an obstacle that cannot be engineered away. A world stripped bare will not easily be made whole, and so the question sharpens. Can ambition triumph over planetary history? Or is Mars's flaw, etched in its very skeleton, the final barrier to humanity's greatest dream? Every dream begins with a light. Mars glows in the darkness as a beacon of ambition, a red world that has haunted human imagination for centuries. It seems so close, so attainable, as if destiny itself has placed it within reach. Yet the closer the gaze, the sharper the shadow becomes. Beneath the poetry of its glow lies a truth more unyielding than desert stone. Mars is a world defined by its absence, of air, of protection, of permanence. And in this absence lies the fatal flaw that no vision has yet overcome. At the center of this flaw is gravity. Mars is a smaller sibling to Earth, only about half the size and with little more than 1/3 the surface gravity. This difference, so subtle in numbers, is profound in consequence. Gravity is the silent hand that holds a planet's air close. On Earth, it binds oceans, rivers, and an atmosphere thick enough to cradle life. On Mars, the grip is weak. Its atmosphere thins, drifting into space like smoke from a fading fire. Any attempt to thicken it is doomed to erosion. No matter how much gas is released, no matter how much water is vaporized or carbon dioxide is freed from the poles, Mars cannot keep its sky. Its gravity will always let it slip away. The weakness does not end there. Without a molten core in motion, Mars cannot generate a global magnetic field. The magnetosphere is Earth's invisible shield, the barrier that deflects the solar wind and guards the atmosphere from destruction. Without it, the atmosphere of Mars is exposed. Charged particles from the sun slam into its upper layers, stripping atoms into space. What remains is a thin, fragile veil of carbon dioxide, only 1% the thickness of Earth's air. Beneath this veil, liquid water cannot endure. Pressure is too low, radiation too high, and the sky too unkind. This is not conjecture. NASA's MAVEN mission has recorded the escape of atmospheric gases even today, measuring the loss in real time as solar storms buffet the planet. Each flare from the sun peels away more of what little remains. Mars has been bleeding air for billions of years, and the wound cannot be closed. The result is a paradox. Mars invites settlement because it is near, because it carries ice at its poles and beneath its soil, because its days are almost the same length as Earth's. Yet the very skeleton of the planet resists permanence. Its gravity ensures that any atmosphere will be temporary. Its lack of a magnetic shield ensures that radiation will always fall unhindered across its surface. Colonization is not merely an engineering challenge. It is an argument with the laws of physics themselves. Terraforming has been imagined in countless forms. Science fiction has painted skies of blue above Martian deserts, oceans spreading once more across the northern plains, forests rising where today only dust storms wander. Some propose releasing greenhouse gases from the soil and polar ice, thickening the air until warmth returns. Others imagine redirecting comets to deliver water and atmosphere in crashing abundance. Still others dream of magnetic shields placed in space, artificial guardians to hold back the solar wind. But the flaw remains. Even if Mars is given an atmosphere, its weak gravity will allow it to slip away again. Even if shields are built, the planet itself cannot sustain what Earth sustains. Terraforming is not creation. It is a battle against time, against inevitability. The scientific consensus is sobering. With current understanding, no amount of technology can rewrite the physics of a small, cooled world. This flaw casts a shadow across the dream of Earth 2.0. It forces reflection on the limits of ambition. Can technology outwit planetary destiny? Can humanity impose permanence on a world that has already chosen desolation? Stephen Hawking, one of the greatest minds of modern physics, warned of the fragility of Earth and the urgency of finding a second home among the stars. He spoke of the risks of climate change, of nuclear war, of existential dangers that could end humanity's story. His voice carried the conviction that humanity must look outward, that survival depends on becoming a multiplanetary species. Yet even Hawking acknowledged the weight of planetary limits. To move into space is not only to build rockets, it is to confront the truth that not every world can be tamed. Mars embodies that truth. Its deserts are not the problem. Its thin air is not the only challenge. The flaw is deeper, etched into the planet's essence. Mars cannot hold what Earth holds. Its skies will always be thinner, its shield always absent, its gravity always too weak. No city, no dome, no machine can change this. Humanity may endure there, but the planet itself will never become a second Earth. The philosophical edge of this realization cuts sharply. If the dream of Mars cannot overcome its flaw, what does that say about ambition itself? Technology can build habitats shielded underground or beneath domes. It can transport water, recycle air, and generate artificial environments in bubbles of protection. But to build a world, to create a living sky requires more than engineering. It requires the cooperation of the planet itself. Mars does not offer that cooperation. It resists silently but firmly, with every law of physics on its side. There is tragedy in this knowledge. A tragedy not of failure but of recognition. Mars holds within its rocks the memory of oceans, the chemistry of life, the echoes of a world that once had promise. It is a monument to what could have been. To stand on its surface would be to feel the weight of that history pressing down like the thin air, reminding that nature is not bound to human will. The flaw unveiled is not simply a scientific fact. It is a philosophical revelation. Some doors are closed not by choice but by destiny, yet the story is not without hope. Even in resistance, Mars challenges the imagination. If it cannot be made into Earth 2.0, perhaps it can become something else. A world of research and discovery. A frontier of adaptation, where humans learn to live not by bending planets to their will, but by bending themselves to planetary truth. Underground habitats may thrive, shielded from radiation by rock. Greenhouses may bloom under domes, sustained by technology rather than climate. Mars may never be a second Earth, but it may yet be a chapter in the story of humanity's survival. The flaw is unveiled, stark and immovable. Mars cannot hold its air, cannot shield its surface, cannot sustain life as Earth does. But in that flaw lies the ultimate test. Humanity must decide whether ambition is the power to transform or the humility to adapt, whether survival lies in conquering nature or in learning to live within its boundaries. The red lantern of the cosmos shines on, both promise and warning. It invites with beauty and resists with physics. It asks a question written into its very stone. When destiny itself is written by the laws of nature, can humanity's will ever rewrite the script? To dream of Mars is to dream of transformation. For as long as its desolate images have reached Earth, there has been a question whispered through laboratories, novels, and space agencies alike. Could Mars be remade? Could this barren world, stripped of its oceans and atmosphere, be coaxed back into the likeness of Earth? The vision is as old as the realization of Mars's loss. If the planet once had rivers, perhaps rivers could flow again. If it once had a thicker sky, perhaps its atmosphere could be rebuilt. In the imagination of science fiction, this was never impossible. Vast machines turned deserts into fields. Oceans were summoned from ice. A red planet became a green one, transformed into Earth's twin by human hands. Yet as science moved from fantasy into physics, the details of this dream began to take shape, and with them, the magnitude of the challenge revealed itself. One idea begins at the poles. Mars's ice caps hold carbon dioxide frozen in layered sheets, locked away in silence. If this CO2 could be released into the air, it would thicken the atmosphere and trap heat, creating a greenhouse effect strong enough to warm the planet. Some suggest giant factories designed to pump heat into the caps. Others propose darkening them with dust to absorb sunlight, or detonating devices to release their frozen gases all at once. The goal would be to awaken Mars from its frozen state by letting it breathe its ancient atmosphere again. A second vision looks upward, not downward. Enormous mirrors placed in orbit around Mars could reflect sunlight back onto its surface. They would act as artificial suns, focusing beams of heat on the poles, warming the ground, and triggering the release of gases. Such mirrors would need to be tens of kilometers across, built in the void of space, suspended like sails of light. Their reflections could ignite cascades of change, melting ice, thickening air, and starting a chain of feedbacks that might restore warmth to the planet. A third proposal, more dramatic, emerged from the voice of Elon Musk: nuke Mars. The idea is to detonate nuclear weapons above the poles, creating pulses of heat that vaporize CO2 ice and release massive volumes of gas into the atmosphere. The explosions would not destroy the planet, but they would serve as violent matches, attempting to relight a climate long extinguished. The vision is bold, perhaps reckless, but it captures the desperation of a dream facing impossible odds. Beyond heat, there is the question of protection. Even if the air could be thickened, the solar wind would still strip it away, just as it has for billions of years. Without a magnetic shield, any new atmosphere would be temporary, leaking into space over millennia. Some scientists have proposed a solution both elegant and audacious: place an artificial magnetosphere at Mars's L1 point, the position in space where the gravitational pull of the planet and the sun balance. A great magnetic generator stationed there could act as a shield, deflecting the solar wind before it ever reached Mars. In theory, this could give the planet time to hold on to its new atmosphere, a manufactured guardian to replace the one nature withdrew. Each idea carries weight. Each is rooted in science, not fantasy. But each demands energy on scales that challenge comprehension. Releasing CO2 from the poles would require heat on a planetary level. Building orbital mirrors would mean constructing structures larger than any humanity has ever imagined. Nuclear detonations might release gas, but only a fraction of what is needed to create true warmth. A magnetic shield at L1 would demand technology and power far beyond anything yet built. And even if all were possible, the flaw waits in silence. Mars's surface gravity is too weak. Its hold on air is tenuous. Any atmosphere, once restored, would slowly bleed into space again. It might last for centuries, perhaps even millennia, but not forever. In cosmic time, it would be only a pause. Every solution becomes a patch, a temporary reprieve against inevitability. The closer scientists come to modeling the details, the heavier the impossibility feels. Studies suggest that even if all known reserves of carbon dioxide on Mars were released, the atmosphere would still be less than 1/10 the density of Earth's. Not enough to sustain liquid water. Not enough to shield from radiation. Not enough to create a world where humans could walk beneath an open sky. The dream falters under the numbers. The materials simply are not there. The energy required is beyond the reach of industry. The flaw reveals itself not as a challenge, but as a wall. Yet the dream persists. Because it is not only scientific, it is emotional. It is philosophical. To imagine Mars terraformed is to imagine that humanity can master the forces that shaped worlds, that deserts can bloom, that barren stones can sing with rivers, that destiny itself can be rewritten. To surrender the dream feels like surrendering to limitation, and so it lingers, fragile but unyielding, even as the facts stack against it. There is poignancy in this struggle. Mars seems to sit forever on the edge of possibility, a world that tempts with familiarity but denies permanence. The more solutions are imagined, the more the flaw asserts itself. The closer we come to unveiling the mechanics, the clearer the impossibility becomes. It is as if the planet itself resists, its silence reminding that not every world can be remade in Earth's image. Still, within this resistance lies meaning. Perhaps the dream of terraforming is less about Mars itself and more about humanity's reflection. To yearn to change Mars is to yearn to transcend boundaries, to face impossibility and push against it, even knowing the odds. In that sense, the dream is not wasted. It becomes a story of ambition, of persistence, of a species unwilling to accept the limits of one cradle. But beneath that story is the lesson Mars whispers through its deserts. Not every flaw can be solved. Not every world can be saved. And sometimes the act of striving reveals not how powerful humanity is, but how fragile. Mars remains, a red lantern against the stars, its flaw unveiled again and again. The atmosphere slips. The shield is gone. The gravity is weak. Every dream of transformation circles back to the same truth. The closer it comes to life, the more impossible it feels. And yet, the dream endures. Not because it is easy, not because it is certain, but because in the struggle itself, humanity finds its reflection, the need to reach, even when the sky says no. To imagine life on Mars is to imagine life lived in shadow. For while the dream paints cities beneath a crimson horizon, the reality speaks of survival beneath the soil, hidden away from the sky that draws humanity to the planet in the first place. Mars, stripped bare of its shield, drenched in radiation and cold, demands refuge not upon its surface but beneath it. The solutions being explored are not visions of vast open plains reborn with forests, nor of oceans stretching across the northern lowlands. They are solutions of necessity. They are shelters carved into the bones of the planet, places where humanity would retreat from the very environment it longs to conquer. Underground habitats form the first vision. Mars is riddled with lava tubes, vast hollow tunnels left behind by ancient volcanic flows. On Earth, such tubes can stretch for miles, protected by thick ceilings of stone. On Mars, they could be larger still, uncollapsed thanks to the lower gravity. These caverns offer natural fortresses, their roofs shielding against radiation, their isolation buffering against temperature extremes. To settle Mars may mean never standing beneath its open sky, but instead living in chambers carved by fire billions of years ago. NASA has studied such possibilities, imagining habitats sealed within these tubes, connected by airlocks and powered by nuclear or solar grids. The European Space Agency has explored similar ideas, mapping cave entrances that could one day shelter explorers. To inhabit Mars may mean becoming a subterranean species, existing not on the planet's face but within its hollow veins. Where tubes are not available, domes of human design are imagined. Protective bases built from Martian regolith, the loose soil and dust covering its surface, could shield inhabitants from the constant storm of radiation. By layering this soil over habitats, engineers could mimic the protective depth of Earth's atmosphere and magnetic field. A few meters of rock above a habitat could mean the difference between safe living and lethal exposure. Concepts of biospheres, enclosed ecosystems with plants, recycled air, and water extend this vision. A fragile Earth recreated beneath an alien crust. The science is sound. Radiation on Mars's surface is measured at about 240 millisieverts per year, several times higher than the average annual dose on Earth. Over a lifetime, unprotected, it would be lethal. To survive requires walls of stone or regolith, barriers thick enough to imitate what Mars itself no longer provides. The shelters are not imagination. They are necessity, drawn from physics, written in data returned by rovers and orbiters. Yet the deeper truth lies not in science, but in philosophy. For what would it mean for humanity to settle on a world it cannot truly inhabit? To walk on Mars only in suits, to see its sky only through domes, to breathe its air only through machines. The colonists would be exiles, their lives bound to the underground, their days measured not by freedom but by protection. This vision is survival, but is it colonization? Colonization carries with it the sense of permanence, of belonging, of shaping a place into a home. Yet Mars resists this belonging. Its sky remains unbreathable, its soil toxic, its air thin and fleeting. Even with domes and tubes, humanity would live not with the planet but against it. The relationship is one of retreat, not embrace. Here arises the echo of Plato's cave. In his allegory, prisoners lived chained in darkness, seeing only shadows of reality cast upon a wall. To them, the shadows became the world, though the true world lay beyond their sight. Life on Mars might carry the same paradox. Beneath the soil, within tubes and domes, humans would see only reflections of freedom. Artificial skies projected on ceilings, simulated Earths within chambers. The real world, the red sky, the alien horizon, would remain forever beyond reach, too dangerous to inhabit openly. Colonists would not live upon Mars. They would live beneath it, in exile from the very world they had sought. The psychological weight of such existence cannot be ignored. To live for years, for lifetimes in artificial habitats, to walk outside only in fragile suits, to never breathe the air of the world one stands upon, this is more than physical exile. It is existential exile. The human spirit has always longed for horizons, for open skies, for the freedom of nature. Mars offers only confinement, survival in silence, a life forever mediated by walls and machines. NASA studies do not ignore this. The challenge of Mars is not only technical, it is psychological. Simulated missions on Earth, such as those in the HIC's dome in Hawaii, reveal how confinement strains the mind, how isolation reshapes perception. 6 people sealed for months reported loneliness, conflict, and the weight of repetition. On Mars, there would be no relief beyond the walls, no true escape into the open. The colonists would live always as prisoners, their freedom bounded by their protection. And yet, there is meaning even here. To endure beneath the red sky is to face the deepest test of humanity's resilience. It is to accept exile in pursuit of survival. It is to live not in comfort, but in defiance, choosing continuity of life over the luxury of freedom. Colonization of Mars, then, may never be colonization in the traditional sense. It may always be survival against a flaw too deep to erase. Still, the allure of the red sky remains. Even if humanity must live beneath it, the symbolism of presence cannot be erased. To step onto another world, to survive within its bones, is to prove that life can reach beyond its cradle. Even in exile, even in confinement, the act itself carries weight. But the question lingers heavy as stone. Is this victory or concession? Is it humanity's triumph over the void, or its submission to limits it cannot overcome? To live beneath Mars is to live in the shadows of freedom, sustained by echoes of Earth but never by Mars itself. It is existence, not belonging. Survival, not home. Perhaps that is the truest lesson of the flaw. Not that humanity cannot reach other worlds, but that reaching is not the same as possessing. Mars may host human survival, but it may never host human belonging. Its skies will never be breathed. Its fields will never be tilled beneath the open sun. Its rivers will never flow again as they once did. To live there is to accept this exile, to embrace survival without illusion. And so Mars remains both promise and paradox. A world within reach but not within embrace. A place where humanity can live but not belong. A mirror of ambition, reflecting not what humans can take but what they must accept. Life beneath the red sky is life within boundaries, life in shadow. It is a reminder that the universe is not obliged to give what is desired. It offers only what is possible, and in that possibility, humanity must decide whether survival without freedom is enough. The red sky will always burn above, untouched and untouchable. Beneath it, in tubes of stone and domes of soil, humans may endure. But the truth cannot be erased. This is not colonization. This is survival in exile. Mars is not easily conquered. Its flaw is not a single obstacle that can be engineered away, but a destiny written into its very bones. Weak gravity, a vanished magnetosphere, a sky too thin to breathe, too fragile to hold. The more it is studied, the clearer the flaw becomes and the heavier the dream feels. Yet still, science resists surrender. Where nature places walls, imagination begins to draw doors. The most ambitious ideas begin with the shield Mars has lost. Without protection from the solar wind, no atmosphere can endure. But could humanity build its own? Scientists at NASA have proposed a vision almost mythic in scale, an artificial magnetosphere. It would not be placed on the surface nor deep beneath the soil, but in space itself. At Mars's L1 point, a position where the pull of the Sun and Mars balance, a powerful magnetic generator could stand guard. It would act as a shield against the solar wind, deflecting the charged particles that have scoured the planet for eons. With time, the atmosphere might thicken, warmed by greenhouse gases and strengthened by protection. The red world might once again grow skies blue enough to catch the breath, but the scale of such a machine stretches the imagination. It would demand power beyond anything humanity has ever built, a monument not of stone, but of electromagnetism and plasma, holding back a star's fury for a world millions of kilometers away. It is a dream of super-engineering, a structure not only planetary in ambition, but cosmic in its defiance. Other visions take a different path. Some propose importing volatiles, water, ammonia, methane, from comets and icy moons. Redirected across the solar system, these wandering bodies could crash into Mars, delivering oceans and air in violent abundance. A single comet holds more water than entire regions of Mars combined. 1,000 such impacts could remake the surface in floods and clouds. But such a plan carries its own impossibility. To steer comets is to wield forces of apocalyptic energy. The risks to Earth alone make the idea almost unthinkable. To miss Mars by fractions of a degree would mean disaster for the cradle humanity still calls home. And yet, these ideas are not dismissed entirely. They linger in academic papers, in theoretical studies, in the whispered corridors of science where the line between boldness and impossibility is thin. They are not fantasies, but speculations, reminders of the lengths humanity might one day travel in defiance of fate. At the root of all such visions lies power. To bend a planet's climate requires energy on scales humanity has never commanded. Nuclear fission, the splitting of atoms, is too weak, too limited. But nuclear fusion, the power of stars themselves, offers a path forward. If controlled, fusion could unleash the energy needed to build shields, to redirect comets, to drive machines large enough to alter the skies of worlds. Fusion has always been the dream of abundance, the key to unlocking scales of engineering so vast they border on the divine. Perhaps in a future where fusion burns steadily in reactors, humanity will wield the fire needed to challenge Mars's flaw. Beyond fusion lies even greater speculation. Dyson-scale engineering, the harnessing of energy on planetary and stellar scales. Such visions imagine swarms of solar collectors orbiting the sun, channeling power not for cities but for worlds. With energy drawn from a star, even the flaws of Mars might be addressed. Shields could be built. Skies could be sustained. Atmospheres could be held against the pull of time. It is speculation, yes, but speculation born from physics, from the simple fact that energy exists in abundance. The question is not whether it exists, but whether humanity can ever learn to use it on such scales. But perhaps the flaw cannot be solved by changing Mars. Perhaps it can only be solved by changing humanity. Radiation, cold, low pressure, all are lethal to biology shaped on Earth. Yet biology is not fixed. Genetic engineering already reshapes crops, medicines, and animals. Could it reshape humans themselves? Could DNA be altered to withstand radiation, to thrive in thinner air, to survive where Earth-born lungs and skin cannot? It is a question that stirs both hope and unease. To adapt Mars to humanity is to dream of terraforming. To adapt humanity to Mars is to dream of a different kind of transformation, one not of worlds, but of identity. The ethics ripple outward like echoes. If humanity alters itself to live on Mars, what remains of what is human? Are those descendants of Earth or a new species entirely, born of necessity and exile? And which path is more honest? To force Mars into the image of Earth, or to let humanity evolve into the image Mars demands? Einstein once wrote that the most incomprehensible thing about the universe is that it is comprehensible at all. His theories of relativity reshaped understanding of time, gravity, and the fabric of space. They remind that what seems impossible in one age may be inevitable in another. Mars may resist now, but time itself is vast. Science may grow, technologies may rise, and what today is speculation may tomorrow be practice. The flaw feels immovable only because humanity has not yet learned how to move it. And yet, even as the future holds its promises, the present holds its lessons. Mars teaches humility. It reminds that physics is not an adversary to be defeated, but a teacher whose boundaries define possibility. Its flaw is not cruelty, but truth. Gravity is weak because the planet is small. The magnetosphere is gone because the core has cooled. The atmosphere is thin because time has stripped it bare. These are not punishments, but facts. To fight them is to struggle with reality itself. In this sense, Mars is more than a dream of colonization. It is a mirror. It reflects both the limits of power and the boundlessness of imagination. Science against fate is not only a struggle to overcome. It is a dialogue with the universe. Every plan, from magnetic shields to fusion, is less about Mars itself than about humanity's refusal to accept silence. To reach for Mars is to declare that flaws, however deep, are not reasons to surrender, but reasons to strive. Perhaps in centuries to come, fusion reactors will hum in orbit, magnetic sails will shield the red world, and genetically engineered humans will walk its surface without fear. Perhaps Mars will be clothed again in skies that hold, or perhaps the flaw will endure, unbroken, and Mars will remain forever a world of exile, its skies seen only through glass, its soil touched only in suits. Either way, the lesson remains. Mars forces the recognition that ambition must bow before physics, and that humility is as essential to exploration as courage. The red world stands silent, stripped, unyielding. It is a challenge written into stone and sky. Science pushes against it with visions vast as stars, but the flaw persists, reminding that fate is not easily overturned. Yet in that struggle lies meaning. For even if Mars cannot be remade, the effort to try reshapes humanity itself. Mars does not simply ask whether it can be tamed. It asks whether humanity can live with limits, or whether it will forever strive to write new chapters beyond them. Mars lingers in the human imagination like a dream that always slips from reach. It burns in the night sky as a red lantern, close enough to inspire, distant enough to resist. For centuries, it has been the mirror of ambition, the stage for both gods and science, myth and mathematics. Yet when the veil is pulled back, when its deserts are seen in detail, when its history is read in stone, the truth emerges with unrelenting clarity. Mars is a world shaped by loss. Its flaw is not hidden. It is written in every dried valley, every frozen pole, every breathless sky. The paradox is haunting. Humanity is drawn to Mars because it feels familiar, because its landscapes echo Earth's own, because its past once rhymed with rivers and seas. Yet that same familiarity is deceptive. Mars promises home but offers exile. It looks like a second Earth, but it resists like no Earth ever could. Its flaw, its weak gravity, its vanished shield, its barren sky, reminds that not every world is meant to cradle life. Some are destined for silence. And so the question becomes not only scientific but philosophical. Why? In an age of rising seas and burning forests on Earth, does humanity pour so much of its imagination into another world? Why does the red planet call so strongly when the blue planet beneath our feet still trembles with need? Is the longing for Mars an escape, or is it a mirror of a deeper truth? That humanity is restless, forever reaching, unable to be content with one cradle, even if that cradle is breaking. Mars embodies this obsession. It is the eternal frontier, the place where possibility and impossibility meet. To colonize Mars has been framed as survival, as insurance against catastrophe. But perhaps in its silence, Mars asks a different question. What if the truest path of survival is not to escape, but to preserve? What if the warning carved into Mars is not an invitation to flee Earth, but a reminder to care for it? For Mars was once alive with promise. It held rivers and lakes. It may have nurtured the conditions for life, and then it lost them. The shield failed, the air thinned, the waters fled, and the silence spread. To study Mars is to confront the fragility of habitability itself. The same physics that stripped one world could, in time, threaten another. Earth's shield still holds, but it is not infinite. Its balance is delicate, its climate vulnerable. Mars is not only a dream. It is a warning written across the sky. Yet the human heart resists warnings as much as it resists walls. The flaw of Mars may not be solvable, yet the effort to solve it has shaped visions of fusion, shields, mirrors, and machines vast enough to rival planets. It has driven speculation about altering biology itself, about bending DNA to survive where atmospheres fail. These visions are not wasted. Even if they never cloak Mars in air, they stretch the imagination, teaching what it means to dream at scales beyond the present. In striving against impossibility, humanity learns what it is capable of, even when success remains out of reach. Perhaps then, the flaw is not meant to be erased. Perhaps it is meant to be understood. Mars stands as a teacher, a reminder that ambition must live alongside humility. The universe is not built for human comfort. It is vast, indifferent, ruled by physics that bend for no one. To step into that vastness is to accept that not every world can be tamed, not every horizon conquered. The value lies not only in what can be claimed, but in what can be learned. Still, the unanswered questions linger like shadows on the horizon. Is Mars forever lost to life, a desert sealed by fate? Or will some future civilization, armed with sciences yet unimagined, return to its deserts and rewrite its destiny? Perhaps one day gravity itself will be engineered, or magnetic fields woven from plasma and energy vast as stars. Perhaps the flaw, unyielding today, will dissolve in the hands of descendants who command tools we cannot even name. Time itself is long enough for such possibilities. The universe is patient. Civilizations rise and fall in the span of an eye to the cosmos. If humanity survives, it may grow into powers that make today's impossibilities seem small. To the eyes of that future, Mars may not be a lost world, but a world awaiting rebirth. But until that future, Mars remains what it is now, a dream suspended between reach and resistance. It stands as a monument to ambition, a mirror of fragility, a reminder that physics holds sway over even the boldest visions. Its flaw is not just a planetary fact. It is part of the human story. It reveals limits, but it also ignites will. For even knowing its resistance, humanity still reaches. Even knowing its exile, humanity still dreams of its embrace. There is beauty in that defiance. To reach for Mars is not to guarantee success, but to affirm the essence of what it means to be human. To confront the impossible and still extend a hand toward it. To see deserts and imagine oceans. To face silence and imagine voices. To see exile and still imagine home. Mars glows in the night sky, eternal and untouchable, carrying the memory of a world that once might have been alive. It will remain there, a red lantern above the horizon, a question written in fire. Perhaps it will never be solved. Perhaps it is not meant to be solved. But its presence ensures that humanity will never cease to wonder, never cease to reach, never cease to ask what lies beyond. In the end, the flaw of Mars is not only written into the planet, it is written into us.
It is the mark of a species that refuses stillness, that dreams even against the silence of physics.
It is a reminder of both fragility and resilience. Mars may never be home, but it will forever be a part of humanity's story. A story not of conquest, but of longing. A story not of possession, but of reaching. A story that, like the red world itself, burns eternal in the dark.